These are the solutions to CCEA's GCSE Further Mathematics, Unit 3, which is a statistics module, and this is for summer 2026. If you like these solutions, revision courses are available at nimathstutor.co.uk, and they're available for GCSE Higher Maths, GCSE Further Maths, AS, and A2 level mathematics. Right. You've got a few formulas here. You've got your normal probability tables as well, as we'll see them later on coming into play. First question says, Rudolph owns a Christmas tree farm. The height in meters of 100 Christmas trees taken from the farm were measured with the following results. Calculate the estimate of the mean height. There is a way to do this a lot quicker on the calculator, but because of how they've set this out at GCSE level, we really think that they want you to do the long way, which is the following. So the first thing you've got to do is find the midpoint, x, and you're finding the midpoints of all these things here. So what you're doing is just adding the two n values. So the 0.5 and the 1.0, add the two of them and then divide by 2. When you do that, what you get is 0.75. The next one, you're adding 1 and 1.2 and then dividing by 2, you get 1.1. Do that all the way along. 1.2 plus 1.6 divided by 2 is 1.4. 1.6 plus 1.8 divided by 2 is 1.7. 1.8 plus 2.0 is 1.9. 1.8 plus 2.0 and then divide by 2 is 1.9, and 2.0 plus 2.4 and divide by 2 is 2.2. Right, this is your F column. This is obviously your X column. You want to find an FX column and an FX squared column, because you need for this sigma F, which is the sum of your F column, sigma fx, which is the sum of your fx column, and sigma fx squared, which is the sum of your fx squared column. Don't be surprised if this one, or definitely this one, either of these are very, very big numbers. Quite often that is the case. Might not be the case in this one because our x values are actually quite small, but quite often these can be like in the hundreds of thousands, especially your fx squared one in a question like this. Okay, add up your frequency. I'll just do that first, and I got 100. And of course, it should have been 100 because we're 100 Christmas trees. How you get your fx? To get this fx, you do 8 times the 0.75, which gives you 6. 23 times the 1.1, which gives you 25.3. 47 times 1.4, 65.8. I've already done these out, by the way. 16 times 1.7, which is 27.2. 5 times 1.9, which is 9.5. 1 times 2.2, which is 2.2. Added those up, I got 136. Looks about right, yep. And my fx squared. Now, how you get your fx squared? You can either do this number times 0.75 squared to give you 4.5, or you could just do the 6 times another 0.75, which again is going to give you the same thing. So the next one, so I would probably just think the quickest way to do it is that multiply the last two columns. So the 25.3 times 1.1 gives you 27.83. Then next one, 92.12, 46.24. Check all of these, please. 18.05, 4.84. And when I added those up, I got 193.58. Now, calculate an estimate of the mean. Why it's an estimate, by the way, is we have no idea what the values were what the exact values are. So we had to use these midpoint values to make an assumption. Basically, this is why it's an estimate. Okay, but so your mean, we'll use a proper notation. X bar is sigma fx divided by sigma f. You've got those things written down. So x bar in this case is my sigma fx, which is 136 divided by 100, which is just going to be equal to then 1.36, and you write that in the answer line there. Next bit says find an estimate of the standard deviation. You must show you're working out. So I'm just going to say SD, which is standard deviation, is going to be square rooting all of this, by the way, sigma x squared over sigma f minus and sigma fx over sigma f, and that bit is squared. You may have just wanted to write that bit. That's the same as your mean squared. I just like to write it out the other way, I have to say, but personal preference. And then 193.58 over 100 minus 136 over 100. That bit is squared. And the square root of all that, I got 0.293598. And I forgot to say this at the start. If you look back at the front of the page, it said, front of the exam paper, it said give your answers to 2 decimal places where appropriate. So 0.29 is what we're looking for. Next bit says, for marketing purposes, Christmas trees are potted to be sold, and the total height is given in feet. Root of works out the heights of the potted trees in feet. Root of works out the heights of the potted trees in feet by multiplying by 3.3 and adding 1. What is an estimate value for the mean of the potted trees? What a great question. Right, the mean was 1.36, and what he does to every single height, he multiplies them all by 0.33 and then adds 1. So if you do that, you get 1.45, and that's it, to 2 decimal places. Okay. The standard deviation. Now, the standard deviation is a wee bit different. You multiply by 0.33 and then you add 1. Now, let's just do a little diagram to show. Right, you can imagine here, there's my values. And then if I multiply them by a number, they get more spread out. But adding 1 would just shift them all up by 1. So they're just shifted up by 1, so they're still the same amount of spread. They're just 1 up, and that's what the standard deviation is. It's a measure of spread. So when you multiply by 0.33, that has an impact, but adding 1, as it makes it, well, in this case, less spread out, but it changes the spread, we'll just say. But adding 1 does not change how spread out something, because everything's getting added 1, everything's just shifting up by 1. But when you multiply by 0.33, you get 0.096887734, which is 0.10 to 2 decimal places. So there we go. Next one, what's this? Spearman's rank, is it? Northern Ireland driving theory exam consists of 2 parts, a multiple choice test out of 50 and a hazard perception test out of 75. The marks obtained by 10 students in their multiple choice and hazard perception tests are shown in the table below. And then you've got all of their results. And then what you could do is write down in the table below above the rank orders of the multiple choice and hazard perception tests. Okay, right. I'm going to do these in ascending order. So the smallest first. So the smallest one from the multiple, I'm looking at this line, the smallest one from the multiple choice is a hazard test, or multiple choice test is 25, so I'll put it number 1. The next one then is 29, so it's number 2. Next one is 32, so it's number 3. Next one is 38, so it's number 4. The next one is 39, so it's number 5. The next one is 41, so it's number 6. The next one is, and this is where it gets interesting. The next one is 45 and 45. So that would have been rank 7 and rank 8. Add those and divide by 2, you get 7.5. So this gets called 7.5. This is what's called tied ranks. They're the same. They're both the same rank. So you get 7.5. So one of them would have been like 7th and then 8th. The next one we're going to look at then has to be the 9th. And then that's the 10th. Okay, for the hazard, so we're looking at this row here now. And the smallest one is the 32, so it's here. The next one is the 40, so it's second. The next one is the 47, so it's third. The next one is the 50, so it's fourth. The next one is a 55, so it's fifth. Next one is a 58, it is 6. Next one is a 59, it's 7. Next one is a 60, it is 8. Next one is a 63, it's 9th, and it's 10th. Okay, just looking at this, you can see there's some sort of correlation. What we're going to want to do here is Spearman's rank correlation coefficient. You can see there's some sort of correlation here because quite a few of them completely match up. So I would say there's going to be a fairly strong correlation. And it's a good idea just to make a sort of wee prediction to yourself. Have a look at the thing and think, right, there looks like there is some sort of correlation. I would expect a positive correlation here. We will soon find out. Next bit says for us to calculate Spearman's coefficient of rank correlation. So we've got to do two things here. You've got to do your D and you've got to do your D squared. So D is a difference, and then we're going to square those. So you're just doing 4 minus 5, which is minus 1, 9 minus 7, which is 2, 2 minus 2, which is 0, 7.5 minus 8, which is minus 0.5, 10 minus 10, which is 0, 5 minus 1, 5 minus 4, which is 1, 7.5 minus 9, which is minus 1.5, 1 minus 1 is 0, 3 minus 3 is 0, 6 minus 6 is 0. There we go. And then square all of those. Minus 1 squared is 1, 2 squared is 4, 0 squared is 0, minus 0.5 squared is 0.25, and then that's going to be 0, that's going to be 1, that's going to be 2.25, that's going to be 0, that's going to be 0, that's going to be 0. So a little bit of working out. When you add up all of your D squareds, you get 8.5, right? And we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So your n is equal to 10. So let's write those down over here. Sigma D squared was equal to 8.5, and my n was equal to 10. So your R is 1 minus, this is given on the front of your paper, 1 minus 6 sigma D squared over n upon n squared minus 1. So that's 1 minus 6 times 8.5 over 10 times 10 squared is 100, minus 1 is 99. File that in, and what you get is 0.95 to 2 decimal places. That's what we get with a wee bit of working out. Okay, interpret your results. I haven't given me much space here. I would be inclined to maybe to write more than I need to here, since only 1 mark. Probably what I'm writing is worth 2 marks, but I would definitely just be writing this in. We'll interpret this. This 0.95 indicates a strong positive correlation. Now that may well be enough to give me the marks, okay? But I would also relate it to the real world. So the real world's context in this question is, that means as your multiple choice test result is better, your hazard perception test is better as well. So we'll put that in a nicer way of saying it. So we'll say it indicates that people who do well in the multiple choice do well in the hazard perception. Okay, now I'm guessing because of the lack of space, I probably didn't need to do that, but in general I would be writing both those things in. So what type of correlation? Strong, positive, weak, negative, whatever it happens to be, and then what that means. Okay, right. It says calculate the mean mark for the multiple choice test and the mean mark for the hazard perception. Now what you're doing here is you're adding up all of the multiple choice. So we'll be adding up all of these numbers, seeing what you get, and then dividing by 10. Adding up all these numbers, seeing what you get, and then dividing by 10. That's really what we're doing. So for our working out for this one, so we'll say the mean for the multiple is, when you added those up, I got 390, and then divided by 10, that's 39. The mean for the hazard, it's 530, and then divided by 10, which gives me 53. And obviously you put those in here. I am whizzing through this, I'm not going to bother. That's where you're going to get. Oh, next one. Okay, I should really have done this out. Oh, thankfully, oh, happy days, right? Great. I don't have to do this out the long way, thankfully. What they have done, they have given us, thankfully, they have given us a couple of things. They have given us all the points done out. We just need to put in our mean. So our mean was 3953. So let's put in our mean value, and I'll call that x bar. Y bar was 3953. Let's write that down before I forget it. See me going back and forth. So 3953. There's 39 up here, and 53 is going to be here. So this is my mean point. Now, you've got to plot these tables. They've thankfully given you all the rest of them. Sometimes in exam, you've got to do all this, and it's such a waste of time. So thankfully, whoever made this, been very nice and given us all of this. Okay, now what we want to do is draw a line of best fit, and you will see when you do a mark scheme, you'll see the mark schemes of these, and you'll see your answer can be very different. You've done it correctly, but it's still very different in there, so they have to use what you've done, so you've got to show you're working out. Now, I have put my line of best fit, I'm doing this a wee bit artificially now, but my line of best fit went through this point here. So how I would have done that, I would have put my line through this thing and pivoted it until it looked about right, okay, which is basically what I've done. So when I did it, bear with me, when I did this another day, what I got was my line, which looked very roughly like this. Okay, so that was, it went through this point, and this was a nice whole number, integer coordinate, which was on my line. So I'm going to use this and these 2 points when I have to go on, if I have to go on and do my equation of my line of best fit. Yep, draw a line of best fit and determine the equation of the line of best fit. So again, we're using these 2 points. Okay, so we just need to find the gradient. Remember what we're doing here. Y is equal to mx plus c. This is GCSE level mathematics. Lovely stuff. We're doing our y difference. So your y difference is going to be, I'll do 53 minus 32. My x difference, I'm going to have to do 39 then minus 23. So 39 minus 23. File that in. You get 21 over 16, which is equal to, I'll say that's 1.3125. So that's my m, sorry. Your y is equal to 1.3125 x plus c. And then put in one of the points. I would put in this point. It's just nice to put in that point because everybody's line should have this point on it. Okay, this is a one single point that every single person doing this exam should have this point on. This is the one that your line has to go through. It's the mean value, the x bar, y bar point. So we're going to put that one in. So 39, 53. So 53 is equal to 1.3125 times 39 plus c. That means 53 minus 1.31251 times 39 is equal to your c. Your c works out to be 1.8125. So therefore your y is equal to 1.3125x plus 1.8125. And then, or just say, or it's to 2 different places, 1.31x plus 1.81. And that's it, to 2 dp's. Okay, and we don't have to do anything with it. Sometimes we'll say estimate the whatever it is, a number of hazards whenever you've got a multiple choice score of 50, and then you would put that into the equation. Okay, lovely one here, just filling in the next 2 rows of Pascal's triangle. So how you get these, just to see how you can, they've done something for it. How you got this 2 was you added the 2 numbers above. How you got this 6, you added the 2 numbers above. How you got this 6, you added the 2 numbers above. And there we are. Okay, this always reminds me of Blockbusters. If you're old enough to get that reference, you're very old. Right, here, this is 1, 7, 21, 35, 35, 21, 7, and 1. And then 1, 8, 28, 56, 70, 56, 28, 8, and 1. Okay, now we want to use this, and it says, hence write down the expansion of the p plus q to the power of 8. Now, The coefficients, now what I mean by coefficients, are the number that goes in front of each term, are going to be 1, 8, 28, 56, 70, 56, 28, 8, and 1. And if we do this out, we're going to have our p plus q to the power of 8. So it's going to be 1 times p to the power of 8 plus 8 times p to the power of 7 q to the power of 1 plus 28 p to the power of 6 q squared plus 56 p to the power of 5 q cubed plus 70 p to the power of 4 q to the power of 4 plus, go down to the next line, 56 p to the power of 3 q to the power of 5 plus 28 p squared q to the power of 6 plus 8 p q to the power of 7 plus q to the power of 8. Right, I did that with zero explanation. That's how we go at explaining what I'm actually doing here. Okay, so notice a couple of things. 8 is the power of the p plus q, and these things all add up to 8. They all the way along add up to 8. Next thing I want you to notice is that as my power of p goes down, my power of q goes up. My power of p goes down, my power of q goes up, my power of p goes down, my power of q goes up, my power of p goes down, my power of q goes up. And that happens all the way along until you get to just p to the power of 1 times q to the power of 7. And then really that's p to the power of 0 times q to the power of 8. Lovely. Right, next one says, in a local star supermarket, 60% of customers pay by credit card. One evening there are 8 customers. What is the probability of exactly 2 customers paid by credit card? And give your answer correct to 4 decimal places. So we want to find probably x is equal to 2, and that means you want 2 successes. So you go back to this. 2 successes means we want our p to be the power of 2. So we're going to be using this one here. So it's 28p squared q to the power of 6. So it's 28p squared q to the power of 6. So in this case, that's 28. The probability of success was 60%. So 0.6 squared. If 60% pay by card, 40% or 0.4 don't. And you fire that in, and what I got was 0.04128768. They said in this one 4 decimal places, so 0.0413 to 4 decimal places. Next one says, what is the probability for more than 5 of the customers pay by credit card? Okay, so probably x is greater than 5. That means x equals 6, x equals 7, or x equals 8. So we want our x to be, we want 6 successes. So 6 successes is, do these in green here, it's going to be 6 successes would be this one, 7 successes, p to the power of 7, 8 successes. So those 3 we're looking for. So let's just put them in the order they wanted. That was 28 p to the power of 6q squared plus 8 p to the power of 7q plus p to the power of 8. And if you fire those in, that's 28 times 0.6 to the power of 6 times 0.4 squared plus 8 times 0.6 to the power of 7 times 0.4 plus 0.6 to the power of 8. Fire that into your calculator. Fire that into your calculator and you will get 315,315,39456. Folks, please check everything I have done here. I've done this a long time ago and just doing it now again. Copying from what I have done. So hopefully it's all right. Hopefully it's all accurate. There we are, the 4 DPs. Okay, lovely wee tree diagram question coming up. Okay, Sky Blue Youth Club is planning a family fun weekend on Saturday and Sunday. They are worried that it might rain during the family fun weekend. The club consulted local weather forecasts, which provided the following forecast in the form of probability tree diagram. So There we are. Right. Okay. Oh, sorry. Apologies. I've got enough information here. Right. They've got this sort of half filled in. So it rains on Saturday 0.4. That means it doesn't rain 0.6. And then Sunday, it doesn't rain 0.05, 0.95. So that's going to be 0.05 then for the raining. And then doesn't rain or no rain is 0.1. So that's going to be 0.9. So that's just really all you're doing is that every pair of branches adds to 1. So all of those 3 bits in yellow, the branches have to add up to 1. Likewise, if you had a triple branch, those 3 bits combined have to add up to 1. Okay, complete the tree diagram above, done. Next bit says, calculate the probability that it will rain during the family fun day. So we want to find the probability that it rains. So raining, we'll do this. Here we've got our, to get rains, I'll just do it up here. For it to rain, it's going to be rain and rain. This could be one of our options. Or it could be rain and no rain. Or it could be no rain and then rain. So you could work out all 3 of those. But a much smarter way of doing it would be just to do the only one it's not is 1 minus the probability that there is no rain. So 1 minus 0.6 times 0.1, which is 1 minus 0.06, which is 0.94. Okay, so that's the only way, that's where you're going to get, it's almost certain that it's going to rain. Okay, that's a shame, but there we are. Okay, right, and the next one. Next one says, given that it rained during the family fun weekend, calculate probably that it did not rain on Sunday. No idea. Let's use our conditional formula. So which is this? A given B is equal to the probability of A and B divided by the probability of B. So let's just write out what they've said. It says, given that it rained during the family fun weekend, calculate probably that it did not rain on Sunday. So we'll say not rain on Sunday, given it rained. And that means we'll just say no rain Sunday, and it rained divided by the probability rain. So using that formula in red there, and okay, so no rain on Sunday and it rained. So we've got to find this top line first. So no rain on Sunday and it rains. The only way there's no rain on Sunday and it rains is just going to be that one. That's the only way you can get no rain on Sunday and it raining. It has to rain on the Saturday then. So it has to rain on Saturday and no rain on Sunday. So 0.4 times 0.95, let's just write that in. 0.4 times 0.95. And then bottom line is probably it rained, and we worked that out somewhere to be 0.94. So we're using what we have done before. So 0.94. When we work that out, I got 19 over 47, and for some reason I didn't work that out as a decimal, so I probably would have left it. I guess I'll give it. Hopefully I'll get the marks for that, but I'll give that to 2 decimal places as well, because I had said that at the front of the paper. So 0.40 to 2 decimal places. I would imagine I'd be happy enough if you just left it. I guess the 19 over 47 as it's exact. It's perfect. Okay, the next one. You can see I've already had a bit of fun doing this one out. So I'll get rid of that for you. And the next one. Okay, right, the next one. It says, the times in minutes taken to fly from Belfast to Malaga have a normal distribution with a mean of 190 minutes and a standard deviation of 10. Before I do anything else, I'm going to write that down. My mu, that's my mean, is 190. And my sigma is equal to 10. Now you may not see this, you may not be familiar with this, but your you just say your x is distributed with a normal distribution 190 and then 10 squared. You may not have seen that. If you go on to do A-level mathematics, you'll see that again. But that is where that comes from. That's just how you say how something is distributed. But it's just a nice way of setting it out. But the important thing is your mean is 190 and your standard deviation, your sigma, is 10. Find the probability that a randomly selected flight from Belfast to Malaga takes more than 205 minutes. So I want to find the probability that x is greater than 205. That's what I'm looking to find in this question. So what you've got to do is convert my x value, my real life value, to be a standardized value using the formula z is equal to x minus mu over sigma. So z in this case is 205 minus 190 over my sigma, which is 10. My z works out to be 1.5. So really what I want to find is probably that z is greater than 1.5. I'm going to find this using these tables in front of your paper. We're going to explain how we do this first of all. So really what we want to do is use find this thing here. Right, draw a diagram. Bear with me. It's not going to be pretty. No, that's not bad. It's all right. Happy with that. Right, there's my standardized tables. It has a mean of 0. So two questions I'm going to ask then for people to draw this diagram well. I say first simple question, would 1.5 be to the left of 0 or to the right? Now hopefully you know it's not going to be over here. 1.5 somewhere to the right. That's all you need to know. And then if I want greater than 1.5, do I want to the left of this line or the right of it? So greater than 1.5 again, hopefully you can see this is what we want. Now unfortunately our tables can't do this. The tables can only do up to this bit. So that's what our tables can do. So to get what we want, whoops, what on earth happened there? To get what we want, to get probability that z is greater than 1.5, you've got to do 1 minus the probability that z is less than 1.5. So that's all the tables could do. So that's going to be 1 minus something, and we're going to find this thing using the tables. So now we're over our tables, and you can see I've already done this. So it's bang on 1.5. So 1.5 is 1.5, and then your 0, 0, 0, which is equivalent to then 0.9332. So we're going to write that in. 0.9332. Fire that in, and you will get 0.0668. And there we go. And that's the 4 dPs. It said that in this particular question, that was the 4 dPs. The next one says the times in minutes taken to fly from Belfast to this place in Egypt have a normal distribution, a mean of 387 and a standard deviation of 12. Again, I know you don't really need this, but I just like to do it. Normal 387 and then variance, so sigma squared of 12. So find the probability that a randomly selected flight from Belfast to this place takes more than 6 hours. 6 hours is 6 times 60 minutes, which is going to be 360, of course, and we want it to be more than that. So probably x is greater than 360. That's what we're looking to find. Now, once again, we're going to get rid of all this. We're going to say z is equal to x minus mu over sigma. X minus mu over sigma. So z is equal to 360 minus 387 over 12. And do that out and you will get minus 2.25. Okay, and let's have a look at what. So that means we're looking for the probability that z is greater than minus 2.25. Okay, so we do a wee diagram again, a wee bell-shaped curve, normal distribution curve. Mark on your 0, and then the 2 questions I always ask people, where would minus 2.25 be? Would be left of 0, right of 0? Hopefully we can all see minus 2.25 is left of it. If you want greater than, do you want to the left of the right? You want to the right. Okay, we can't do this, but by symmetry, they're symmetrical curves. So I just flip this around. That's same as 2.25, and it's same as less than. So you can get that directly from the table. So this really is the same as Z is less than 2.25. So you go to your tables. Okay, I've got them here. And there is you go to your 2.2, and your next decimal place is a 5, and you go down, see where they meet. And you can see they meet here at 0.9878. 0.9878 to 4 decimal places. Is this us finished? Is there any more of this paper? Oh, of course there is. One more. Venn diagrams. My least favorite, I have to say. I'm not a fan of Venn diagrams. I don't see them as quick as a lot of people see them. Okay, right. As an opening promotion, a new ice cream shop offers the first 100 customers. Okay, so 100 people in total, up to 3 toppings free of charge. The available toppings were chocolate curls, fudge pieces, and coloured sprinkles. Each of the 100 customers took at least one. Okay, so that means there's nobody in this outside bit. We'll mark it in first. That's a 0 here. So it says 6 choose chocolate curls only. Okay, so that's in here, chocolate curls only. 3 chose fudge pieces only. So that's 3 in here. 9 chose chocolate sprinkles only. That's going to be 9 here. And then it says 47 chose all 3. So that's 47. And then 23 did not choose coloured sprinkles. Okay, 23 did not choose coloured sprinkles. Right, okay. So not coloured sprinkles then would be this, and this. And those 3 have to add up to 23. So that means that allows you to get this middle bit here. So this middle bit here is going to be 23 minus a 6 and minus a 3, which gives you the 14. So that's how we're able to get this as 14. So that's all we can fill in. We can't do anything else at the moment. Unfortunately, that seems to be all we can fill in to this table. Okay, it says using the Venn diagram, find the probability that a customer selected at random chose chocolate curls and fudge pieces, but not chocolate sprinkles. What on earth? Right, chocolate curls and fudge pieces, but not chocolate sprinkles. So that was chocolate curls and fudge pieces. That was this bit here. We've already got this. Happy days. We've already done this. So it was find the probability. There were 14 people out of 100. Let's just write that as 7 over 50, but we'll also write it just in case. Hopefully that's the answer they want, but 0.14 would be the answer as well. Calculate the probability that a customer selected at random chose exactly 2 of the extra toppings. Okay, exactly 2. So for the next bit then, exactly 2 then, we need to find this bit that's highlighted in yellow, this bit, and this bit. Now, we know that all of these numbers, you can imagine if I highlighted everything here, this number, this number, this number, this number, and this number have to add up to 100. So we can forget about the 14. We just want to find the 3 yellow bits in total. So for the next bit, we can just do 100 minus 6, minus 3, minus 47, and minus 9, just to get the 3 yellow. So it's quite tricky. So your calculate the probability. So we'll just say the number for only 2 toppings. There were 100 people altogether, and you take away the 6, you take away the 47, you take away the 3, you take away the 9. That gives you 35. So your answer then is going to be 35 over 100. Give it at 2 decimal places as well, 0.35. Okay, last question. I thought this was tough because I cast my mind back. I remember thinking this was tricky. The probability that a customer selected at random chose chocolate curls given they chose coloured sprinkles was 7 over 11. Let's write that down. So that's probably the curls given sprinkles is equal to 7 over 11. Okay. It says, find the number of customers who chose coloured sprinkles and chocolate curls, but not fudge pieces. No idea. Right. First of all, we'll say we'll work out the total for the sprinkles. So go back to this. How did we work out the total for the sprinkles? Total for the sprinkles. Okay, we know here, we knew that these three things in yellow from our part 2, the three things in yellow added up to be 35. So if you combine this one, if that there are 35 in yellow, 35 minus 14 is going to be 21. So this one plus this one adds up to 21. Okay, so for your total for sprinkles is 21 plus, that was those two bits with circles, plus 47 plus 9, sorry. So it's 21 plus 47 plus 9. And then we just check this. I've done this a slightly different way. I got 77, so I'm hoping I get 77 again. 21 plus 47 plus 9 is 77, yep. Okay, and right. So we've got our total for sprinkles. We're going to need that. And we're going to say, find the number of customers who choose coloured sprinkles and chocolate curls, but not fudge pieces. I'm going to say, let X be the number of chocolate sprinkles and number of curls, but not fudge. Okay, so let's just look at that in the diagram. So basically X is this bit here. That's my X then. All right. Okay, right. Now what we want to do, so this is very difficult, very, very difficult indeed. Okay, so we're looking at the formula for this thing here. This is curls and sprinkles. So curls and sprinkles means curls given sprinkles is equal to the probability curls and sprinkles divided by the probability of sprinkles. Okay, and because we're all out of 100, we could just do it this way. So curls and sprinkles is going to be X plus 47. And then the sprinkles, there were 77. So that was equal to 49 over 70. Sorry, it was equal to 11 over. It's not equal to that at all. Sorry, folks, that's nonsense. It's equal to 7 over 11. It's equal to 7 over 11. And then we can go from there. Okay, so whatever way you want to do it, I would probably just cross multiply at this stage, or else you could take a common denominator. It might be easier. Common denominator of 77. So that's going to be 49 over 77 then is equal to X plus 47 over 77. So what we've got here is we've got, this is a number of customers who choose coloured sprinkles and chocolate curls. So we've got that. So we defined our xn. You're just going to have 49 is equal to X plus 47, which means X is equal to 2. I don't think that's the easiest way of doing that, but it works. Okay, I definitely think there's an easier way. If you do think there's an easier way, please let me know. But that's it. Okay, if you find these helpful, probably haven't found that last question helpful, I can't imagine. But if you find the rest of the solutions helpful, revision course is available at ni-tutor.co.uk.